Right, so we're going to be talking about something that we're generally going to be calling normal distribution. Now, normal distribution is a statistics topic, and it has actually many names, and they're all the same thing. So we're going to call it mostly normal distribution. If you research online, it's also called an empirical curve, EMP, like emperor, empirical curve. It's also known as the bell curve. And among mathematicians, it's also known as what's called a Gaussian curve, Gauss, named after the man who discovered it. It was a mathematician. So all of these things, if you find these topics online or you want to research them, they're all pretty much researching the same thing, normal distribution. This is something to do with statistics, and there's a great example I can give you that's actually very relatable about body temperature. Right now, most of you probably know just from science or just general life that the average body temperature is 98.6 degrees for most human beings when taken orally. Okay, now that's the average temperature. Now we also learned that averages are called X bar. So we'd say X bar, average body temperature, is 98.6. But here's the thing. If you have 98.7 degrees, are you sick just because you're not the average? And of course the answer is no. And if you're at 98.5 degrees, then of course you're not considered sick. You're within a close enough of the average. Remember, this is an average. It's not you have to be exactly that temperature or else you're sick. You just have to be pretty near that temperature. And it turns out, if you I just kind of Googled this, but this actually seems about right and it fits our purposes. You could be anywhere plus or minus 0.9 degrees away from 98.6 and still be considered healthy, which means if you took 98.6 and added 0.9, you would get 99.5 degrees, and that is still considered healthy and normal, right? So anything between those two. Or you can get 98.6 and subtract 0.9, you would get 97.7 degrees, and anything from between here and here is considered a normal temperature, right, for human beings. Okay, animals and whatnot have different temperatures. And of course, where you take your thermometer is different. You know, you can measure on the forehead and the mouth, okay? So depending where you take a temperature, that varies as well. But we're talking the classic oral thermometer temperature, 98.6. But anything within 0.9 degrees above or below that is still considered healthy. So the 98.6 is our range. So what is a 0.9? Well, it is the standard deviation. It means the standard deviation means you can be that much above or below and still be considered in the normal healthy range, okay? So you don't have to be exactly 98.6 temperature. You could be 97.8% or 98.7 degrees. You could be 99.4 degrees, and you'd still be considered healthy because you're within one standard deviation above or below your average temperature. And these two bits of information together is what will create what's called a normal distribution. We're going to make a graph that kind of looks like this. You've probably seen this. This is the classic normal distribution, bell curve, empirical curve, Gaussian curve, whatever you want to call it, right? And the number at the top is the average. It's what most people get. And in this case, it's our X bar. In this case, our X bar is 98.6 degrees. All right, so the line right in the middle of the classic, but all normal distributions look like this. That's why they're called the bell curve. They're kind of shaped like a bell, like the Liberty Bell, similar shape. Okay, so the middle gets the median. And then if you go one standard deviation below it, you know, you'd be at 97.7 degrees. You're still considered healthy. And if you go one standard deviation above this mean to 99.5 degrees, this range is still considered healthy. Now this number and this number, remember this number is the X bar. This number is called the X bar minus the standard deviation. And this number is X bar, 98.6, plus the standard deviation, okay? Now also remember, some books call X bar mu. So sometimes you'll see it written as this, and this would just be called mu. So either way, mu, x bar, they all mean the average minus the standard deviation if you're going below it, or x bar plus the standard deviation if you're going above it. And this range right here, which I'm going to highlight with the yellow marker, is still considered a healthy range. Anyone who has a temperature in that range is not really considered sick. Now, when do you start getting considered sick? Well, if you go too far outside the range, like now you're considered running a fever if you take 99.5 and add another standard deviation to that. Right, so now you're taking x bar and you're adding 2 standard deviations, meaning you're adding 0.9, you're doing 98.6 plus 0.9 plus another 0.9, you would end up getting 100.4 degrees. And that means you're starting to run a fever, right? And I got this from 99.5 plus another 0.9. I keep adding 0.9, I get there. And if I added another 0.9, 100.4 plus another 0.9, I would get 101.3. Right, so I took 98.6 and added 0.9, the standard deviation, to get the 99.5. Then I took the 99.5 and added another 0.9 to get 100.4. And then I took that 100.4 and added another 0.9 to get the 101.3. And all of these numbers here, and of course, there are numbers past 101.9. This actually goes on forever, but it's pretty clear at that point, and actually according to Google, once you start getting into these ranges, or anything above that, because this includes anything above 101.3, so these are considered normal, but this means you're starting to get a fever. All right, so anything above 99.5, and of course, the higher you are above, the bigger your fever is and the more serious it is. All right, and of course, you don't just stop at 100.3, but to be honest, in general, not that many people get fevers above 101.3 unless you're very, very sick. And I once did have 103 once in college. That was the most sick I've ever been. That was very sick. All right, but that's actually pretty rare. It's pretty rare to get temperatures above that range. Okay, and if you do, you clearly have a fever. All right, and this number I got by x bar, and I added not 1, not 2, but I added 3 to get to this number. I added 1, 2, 3 standard deviations. So that's x bar plus 3 standard deviations. Now that's going above. You can also go below the main temperature. So you can take, we took 98.6 minus 0.9 to get this. We can take this number minus another 0.9. You get 96.8. So this number I got by doing x bar minus 2 standard, minus 1 here and then a second one there. Right? Or I can even go lower than that and get 95.9 degrees. And I got this number by doing x bar minus 3 standard. This means I'm 3 standard deviations away from normal. Being within 1 standard deviation above or below is normal. Once you get to 2, you're having some issues, and 3, or even more than 3, because this goes on forever, is more. Right? And I actually looked up online. They don't really have a name for these, but once you get to 95.9 or below, all right, anything below that, you have something called hypothermia. And that means you've been like maybe out in freezing cold weather for hours with no jacket, all right, and you're starting to freeze. That's when your toes turn blue and things like that. And it's very serious. I mean, if they can't get circulation going back in, they might actually have to amputate body parts. It's not great. Okay, so now they don't really have a definition for this. I think that's just normal. I think these are probably just lighter cases of hypothermia. But once you get within 3 standard deviations away, it's very, very serious, right? Like almost life-threatening if you go much below 95.9 degrees, okay? So here's what we did. We actually kind of took all these. Now, it turns out that if you have normal distribution, and to be honest, not everything follows normal distribution, but many things do. Some things do, some things don't. I'll give some counter examples in a moment, but we're going to only work with normal distribution, right? And it turns out that about 34% of all people are between 90.6 and 99.5, and 34% of people, approximately, these are approximations. If you go online, sometimes you see like 34.1%, because different sources have different degrees of accuracy, but this is the ball. We're going to use this one as our ballpark, right? So most people are, about 34% of all people are between 90.6 and 99.5, and 34% of people are below, between 97.7 and 90, in this range, right? How many people are between 99.5 and 104 degrees? It turns out that 13.5% of people would be, and same over here. It's all symmetric, right? How many people would be in this range? Turns out 2.35%, and same over here, which means fewer people are feeling that way, which means that's kind of normal because most people are not sick and very few people have a temperature this high. And once you get to this range, that very few people get to this high of a temperature or this low of a temperature. That's usually a pretty extreme case. So not that many people have it. As it turns out, 0.15% of people, 0.1, not even 15%, not even 1.5%, 0.15% of people would hit these extreme ranges where you are 3 standard deviations away from normal. The yellow range is 1 standard deviation away from normal. These two are 2 standard deviations away. This is 3 standard deviations away, and at the extremes are more than 3 standard deviations away. Okay, so this is kind of the normal term, and it turns out those percents are not completely just random to this case. All right, this is actually taken from your Algebra 2 book, and these are the same numbers I gave you, and this is how the normal distribution works. All right, so these are, here's your mean there. Your X bar is always in the middle. It's always 34% on each side. The next bar is always 13.5, 2.35, and then 0.15%. The normal distribution curves always follow this. And again, here your book used mu instead of X bar, but it's the same thing, all right? This line, this is your mean. This is 1 standard deviation away, above and below, 2 standard deviations away, and 3 standard deviations away, right? Now, if you added up all these percents, I know these numbers look kind of normal, but take a calculator and add 0.15, 2.35, 13 point, and add up all these numbers, you get 1, because this represents 100% of the population, everybody. Right? Everybody falls into one of these ranges. The entire world falls into one of these ranges, and most people are here. Now, most people are 1 above and 1 below. So 34 plus 34, 68% of people are in normal range at any given time. 95% of people are within this range from here to here, all right? So like our triangle here, 99% of people would be in the yellow and these two pink, right? Or 95, right? And then 99.7% of people would be from here to here. Only very few, right? 0.3% of people are in the either very cold or high fever ranges. Okay, so you're going to get kind of familiar with these numbers, and these numbers sadly just kind of have to be memorized, or you need to have your notes out. You're going to refer to these numbers all the time, and you get the numbers at the bottom by starting with your mean and then moving standard deviations away or below. Using that, you can determine how much percent of the population has this. Like, for example, based on this, what percentage of the people in this world have hypothermia? Well, according to this chart, 0.15% of people have hypothermia. What percent of the world has normal temperatures? 34 plus 34, that would be 68% of people currently have a normal temperature, right? What percent of temperatures currently, what percent of people have a fever? Well, you'd actually have to add that up, all right? And I'm gonna get up my calculator, all right? So you do 13.5 plus 2.35 plus 0.5, all right? I'm gonna get that real quick. 13.5 plus 2.35 plus 0.15, and I get 16. So this red area, 16% of people in this red area have a fever, because I just added up this percentage plus this percentage plus this percentage. So that means also 16% of people have a temperature of 99.5 or higher, of more than 99.5 degrees, okay? Hypothermia, only 0.15% of people have hypothermia, and 68% of people are normal, because 34 plus 34. Because remember, just kind of pretty much just memorize this chart. This chart always works for all normal distribution. These percentages work in every single normal distribution case. They don't change. Now, if you don't have a normal distribution, they can change, but we're only going to study normal distribution cases, okay? So using all this information, we're going to draw some of our own normal curves and do some of our own work, all right? So we're going to start with this example right here. All right, this is kind of how you're going to see this and what you're going to do on your own. Okay, so the scores for a math test, this is a typical problem of how you're going to see it and how we're going to do these problems. Okay, so the scores for a math test are normally distributed, which means I am going to use, I don't know if I can find it, means we're going to use this chart. All right, so if I say that they are normally distributed, means this chart applies, so you have to memorize those percents, all right? With a mean of 61, so I don't have to calculate it, I found it on my own, and a standard deviation of 11. So that was also given. Sometimes we could just give you the list and you have to calculate the mean and the standard deviation, and sometimes we just tell them to you if maybe someone calculated it for us. And the tort scores range from 0 to 100, so that means nobody got extra credit with a higher score or anything. Okay, so first step is label the values on a normal curve. Okay, so here we go with step one. So kind of basing everything off of this, I'm going to draw this bell-shaped curve. And I start with the middle, and the middle goes my x bar. Now in this case, my x bar is my mean, and they just told me my mean is 61. So that's it, there's my 61 right there, okay? Now, standard deviation is 11, so that means some people scored 11 points higher than 61. So add 61, add 11 to it, and I get 72. All right. Now, also remember, that's my x bar. I'm going to label the x bar so don't forget it. And then I got that from 61 plus 11 from here, got me 72. Now, some people scored a little lower than 61, so 61 minus 11 turns out to be 50. All right. But let's do all the plus scores first. So we started with 61. I'm going to circle that just to remember that's our baseline. All right. We added 11 to get 72 to get to the next mark, because we need to fill out this whole chart. So we need to fill out we need to find 3 standard deviations in each direction. 3 standard deviations adding and 3 standard deviations subtracting. You always find 3. So 61 plus 11 is 72. 72 plus 11 gets us 83. So you got to figure this all on your own, but you keep adding 11. 83 plus 11 is 94, and I've got 1, 2, 3 numbers past my mean, so I stop. That's it, right? So I did, to get this, just so you know, this is side work, but I got 61 plus 11, that got me the 72. I took 72 plus 11, that got me the 83. I took 83 plus 11, and that got me the 94. And once I get 3 numbers, that's 3 standard deviations away, I stop. Now I got to do the same thing, but instead of adding 11, I'm going to subtract 11. So 61 minus 11 is 50. So here's some extra scratch work. 61 minus 11 got me 50. To get the next number, 50 minus 11. And 50 minus 11 is going to be 39. All right. And then take 39 minus 11, and I am going to get 28. And then I stop there, because once I get to 3 numbers below my mean, that's it. So that is my normal curve, and that is my labeled values. These are the labeled values. These 7 numbers altogether. These are the labeled numbers on my normal curve. So that is actually column number 1. That's it. That's done. Okay? So that is labeling the values on a normal curve. Start with your mean, goes in the middle, and then for these numbers, you're adding standard deviations on this side, and this side you're subtracting standard deviations, right? So whatever your standard deviation is, in this case it's 11, 61 plus 11, 72 plus 11 plus 11, do it 3 times, and then minus. Okay, Now let's go on. That's it. We're done with problem number 1. So let's move to number 2. Now, then we're doing some scary directions, but don't worry. It's just kind of there to cover all the bases and make sure we're only doing the special case. Using the curve from here, find the percentage that a randomly selected x value. These are my x values. So I'm going to pick one at random from the distribution. That means from this list, not some other list, is in the given interval. Now, what does that mean? These are given interval. We want to know what percent of the class, if this is how the scores broke down, what percent of the class has scores between 72 and 83. Now, luckily, it turns out 72, I'll highlight it in yellow for now. Well, actually, no, I'm going to just underline it once. Right, 72 is here, and 83 is here. So it's between, it's this range here. Now, this is where you have to kind of get your notes out, right? Don't forget, they always label like this. The 34s are right on the center. This is 34%. On the other side, it's 13.5. Because the normal curve always fills in like this. And then 2.35. On both sides, it's symmetrical. And then at the very ends, after the last number you did, it's 0.15%. These are all percents. I'm just copying the same percents from here. The only difference is now, instead of these abstract numbers, I actually know the exact numbers. I'm just copying the same percents from here. And the scores between 72 and 83 is this bar right here. And what percentage is in that bar? 13.5%. So to answer question number 2, the answer is 13.5% scored between 72 and 83. That's it. That's all you really have to do. Just fill in the numbers, find the numbers they're asking, if it's between them. Now, well, we'll see other examples, but if it's between them, just pick the number between it, right? Now, number 3, scored at most 50, all right? So now here's 50 on my list, and the scores are at most, so that means maybe they only scored, if they scored more than 50, we're not counting those. At most 50, so maybe they scored 28 or 39 or anything between that. They could have scored 49, right? So that means they're counting anything from, and actually I'll highlight this. So on problem number 2, we were counting just this range, and that's it. On problem number 3, at most 50, we're counting anyone who scored 50 or lower. So these people, and anyone who scored 50 or lower. That's what we're counting up. And so what we need to do is add up all these percentages. So you can get out a calculator if you need to. And we're going to add 13.5 plus 2.35 plus 0.15, and we're going to get 16%. All right, so everyone in this green area, that is 16% of the class. Everyone who scored from 50 or below. Whoops, you can't see that. So it's 16% of the class. Everyone who scored 50%, a score of 50 or lower, all right, that's what at most 50 means, all right? That's going to be 16% of the class. Okay, so that's my answer for number 3. So that one's done. All right, and number 4, at least 83. Okay, we're going to have space, so we'll kind of squeeze it over here. So at least 83. It's around a little bit. So we'll do a number here. Number 4, at least 83. So that means scores 83 or higher. All right, so here's 83. And if it's at least 83, it's 83 or more. So that's all the scores here in this range, right? So that's, add the percentages in that range, all right? So 2.35 plus 0.15, and whoops, I had the wrong number on my calculator for a second. You get 2.5%. So only 2.5 in the class scored 83 or high. That's what at least 83 is. That means the score had to be at least 83. It could have been 83, 84, 85, 86, anything higher than 83. That's what at least 83 means. So that's my answer for number 4. All right. Now, by the way, for this number 2, or the scores are between 72 and 83, the scores could have been anything. We also could have been, let's do a 5th bonus problem. Right? Let's pretend that we're looking for what percent of the class had scores between 50 and 83. What percentage of the class had scores between 50 and 83? Well, here's 50 and here's 83. So that's going to be all the people in this big yellow range, including this one too. So that's all the scores between 50 and 73. So we need to add them all up. So that's going to be 34 plus 34, which is going to be 68, plus 13.5, and that would be 81.5%. And there's my answer. So that's how we use these. One of the ways, there's many ways to use these normal curves and normal distributions. So don't be intimidated by these big directions here. I know that looks a little scary. That's just kind of covering the basis, saying use your normal distribution. These are the randomly selected x values, and given interval means what numbers. Now, some of you might be asked, well, what if the numbers we give is not on here? Then we don't have enough information to solve it. We would have to say, I don't have enough information. I'm not going to do that to you on this test. I'll make sure I pick numbers that are on your chart. But remember, you have to make this chart on your own. Start with your x bar, and then move standard deviation. 3 standard deviations above and 3 standard deviations below. That's what this is saying, yeah? 1, 2, 3 standard deviations above, adding. 1, 2, 3 standard deviations below, subtracting. And see, there's 68% is adding 34 plus 34. 95% will be adding all 4 of these areas. And 97% is adding everything except the 2 extreme ends of the 0.15. And that's just kind of a summation. You don't have to memorize those, but it's kind of handy to have. Okay, so that is kind of the gist of standard deviation. I hope that helps you out.